lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up? What's up? What's up? Tuesday? It's today Tuesday. It is. Nice, and we got a raid from Zach. What's up? I heard, Zach, that you have bequeathed permission for my super janky implicit derivative nonsense. Gesundheit, yeah, I did have a sneeze there. Apparently it's been clipped. Yeah, no, I have it on my soundboard now. Oh, I gotta turn the gain up. Oh, it's gained really low. 1 sec, here we go.
By mathematical authority, it is bequeathed upon you that you may break up the DRDT.
Too funny. Yeah, Brascals told me you guys were doing it. What outrage is in this queue? I don't know. That's Techno, whatever his name is. He loves putting crazy questions. One sec. Let me add this one. This is too funny. I love that Breasticles clip this. I just gotta turn the gain like way up. Yeah. Here we go.
By mathematical authority, it is bequeathed upon you that you may break up the DRDT.
Alright. You're permanently in the soundboard now, Zach. Hello, I observed that you skipped. So yeah, just Kaushik Techno in general. Don't submit questions before the stream starts because I'll just clear them. Yeah. You can submit them once the stream starts, but I'll in general just clear questions if they're submitted beforehand. Because otherwise it just racks up like too many votes. It's question 8 from the JEE Advanced Paper. Yeah. Anytime I see anything that has, what is it? Yeah, this, like, the T to the 2023 power, I know this is like some JEE trick or something. The minimum value of the function defined by what? Yeah, I don't know. And then this one, we might have time to do this one. It's to wrap. Oh man. Yeah, it says difficulty 9 out of 10. Why does it say it's a difficulty 9 out of 10? Advanced calculus problem. It says only 15 minutes to solve it though. I doubt that though. Anyways, we may look at these. The first hour is just kind of open for all the UCLA kids if they want to ask questions. It's kind of easy though if you don't feel like rigorously proving it. Okay. Of course, AI is always right. Yeah.
Oh no.
Definitely not. Anyways, I hope you guys had a fun stream, Zach. There's a lot going on this week, I thought, right? ChatGPT solved a hard integral for you today. Yeah, chat can figure out some stuff pretty well. Because I think what chat does is it kind of peruses everywhere else on the internet, and if it sees it's been solved somewhere, it kind of like stores it into its memory. Yeah, there you go. Yeah, if it's like one of those contest questions or a previous one that's been done, it probably has the solution scraped somewhere. The 2023 power question you can do by observing and thinking. Okay. I don't know how much my thinking is able to do some of these things though. But yeah, what's happening this week? Zach had his stream, cool. I have more teaching Wednesday and Thursday. Friday's technically a holiday because of July 4th. On Saturday, they apparently take the day off before to like observe it. Looks like Penn Center's doing Minecraft and then also Zelda. That's super fun. And then more E&M, more real analysis. And then Friday, yeah, we'll do some games on Friday. I'll pick which games we're gonna do. It might be chess. We've done chess a lot though, so I might switch it up. Say we're gonna do Fortnite or Roblox. The integral from 0 to 0 is always 0. True.
Good job.
Provided I guess it's continuous, going from one form of 0 to another form of 0. Ooh, there's a remake of the Ocarina of Time coming out to Switch 2. Wow, that's cool.
Yeah.
You know, Zelda's the one game I never actually played. I have not played Zelda. Ever. I have it in 64. I never played Majora's Mask or anything. I really just played Super Smash Brothers. Looks like you're buying a Switch 2. Yeah. How much is it? We gave out a Switch 2 last year, actually. As a part of summer camp in August, Kudu sponsored one of the prizes, and I bought a Switch 2 for Ethan. Ethan won the Switch 2 last year. Yeah, they're like $500 now. Oh, I guess $449. Oh, this one's like if you choose a game with it, you get it's $500. Yeah, and it's an OLED screen now too, I think, right? Or no, it's LCD screen? I thought it was OLED. Could have sworn. I Spy, my maths homework from quadratics equations, please. They can sponsor a Switch 2, but not a working. Shots fired, dude.
Oh no.
I mean, yeah. I have a meeting with them tomorrow. Or sorry, on Thursday. I'm gonna reiterate. I need my clicker questions working. Because otherwise, like, my in-class activities are kind of like bunk at this point. Oh no. Oh no, yeah. Yeah, it's okay. It's all part of the debug. I just wish that my class wasn't the QA portion of this. It's a great way to do QA, right? Is to have people run through it. But Yeah, we're having my whole class run through it, and I'm basically it's creating more work for me this summer than I wanted to, because I've already taught this class. I thought it'd be pretty easy for me to just lecture, basically do the same assignments and like teach, but now I'm spending so much time dealing with like bugs and yeah, students saying this doesn't work, and I'm like, man, fuck. Just use iClicker or even Kahoot. Yeah, the issue is that I have to do it because the class is online and it's asynchronous. I have to give people the option to complete it like within 12 hours of me like airing it. I don't know if I could do that with Kahoot, and then also I don't know how Kahoot works with like having a grading a grade book. At least like Kudu has a grade book that everything is in like one CSV that I can then port over to whatever Canvas thing I need to use. But yeah, in an ideal world, everything would just work. So we'll see. We'll get it working. iSpy, if you have a homework question, PChem, I don't know if I can help you with PChem. I can like barely help with OChem. Anything Gen Chem, if it's like first year chemistry, I can totally help you with. But PChem, yeah, that's gonna be a no for me, dog.
Oh no.
Yeah, I don't know very much PChem. Oh, you can assign Kahoots as homework? Okay, that might work. I might look into it, Zach. It's not like a huge deal breaker for me, and honestly, it's something they need to fix, so they're gonna fix it. And I'm trying to optimize the minimum amount of like effort I have to put into running the class. I just want to teach. Like running things is annoying for me. Responding to emails, it's annoying. Let's try some physical chem. Okay, well, you know, hey, iSpy, if you want to submit a screenshot of your question, there's a website for it. Actualofficehours.com. Go there, type in your username, take a screenshot of whatever your homework thing is that you need help with. Something with quadratic equations, sure. Or if it's anything with PChem, just drop it in. Hit upload, and then we'll take a look at it. We'll see if we can solve it. But isn't AI for writing emails? It really is, honestly, but I still have to click on the email, and I still have to say, generate AI response. And then I have to edit it because sometimes the AI doesn't know exactly what like my course policy is. Or, I give exceptions. Some students are like, I had a big family emergency. I had to fly to Doha, and like I wasn't able to do this. Can I get an extension? I'll be like, all right, fine, whatever. I'll give you a day. But I really do like CampusWire. It is great for them like submitting questions and stuff. I've had a good time. Answering all the things they put in there. Super useful. Just mark that as resolved. Okay, cool. But pretty chill so far. Let's see. Yeah, what did we do today? We finished up mechanical waves, and tomorrow we're gonna go into kind of a fun topic for me, which is like sound waves and how it relates to like music. It's a very fun lecture for me. A lot of fun. We did standing waves. I like doing this little derivation, showing how standing waves form using this trig identity. It's cool. If you have like two waves that are going in opposite directions and you sum them, you end up getting like a portion that still oscillates, but then you have a portion that's independent of time and is just dependent on position. And that's how you get the occurrence of all these different standing modes. They're really cool. You got stuck on a geometry problem? Yeah, throw it in the queue. Throw it. I don't see any students yet. They were all here yesterday for office hours. Today, I think because office hours is like an hour later, maybe they're just like, eh.
Oh no.
Like, I don't want to be here. Totally cool. But yeah, traveling waves are cool. This stuff used to scare me so much in college. The idea of like anytime I like saw sine, I was like, wait, what? Now I know it's pretty chill, It just describes, where a wave is as a function of x, and then, if you increase time, increase t, you start like evolving it, in time to the right. It's pretty cool. The honeymoon period is over for the class. Yeah. Yeah, it's about to start getting a little tricky. Throw a test at him, it'll snap him in the line. Yeah, there will be a test. It's not this Friday, it's gonna be next Friday. And by then, I really, really hope that all the Kudu issues are fixed. Because if it fucks up on the test, that's like a big percentage of their grade that, you know, all this stuff with like clickers and homeworks, like I don't care, whatever. It's just like 5-10% here and there. I'm fine just giving them full credit for like the first week or two while things get sorted out. But the exam is supposed to be like something that checks, do you actually understand things? And so if that's having errors, I'm gonna be real upset. Because I don't want to have to rewrite another test. But anyways, yeah, this was cool. I really like this derivation showing how standing waves form. And then this was cool how like superposition works in terms of like phasing. Yeah, you want to post an E&M question? Yeah, I'll take a look at it. We are going to get into E&M not this week. I think by next week. Let me see on my schedule. I got to sign in to UCLA. And then they make... All right, there we go. Let's see. Let's see what's on the syllabus. Oh, this is my old class. Where's my new class? There we go, 261. So, yeah, today we did interference. So constructive, destructive, as well as standing waves. Tomorrow I'm going to do Doppler shift. Oh, okay. Yeah, that has to do with sound and music. And then Thursday's lecture, if you want to come by, Thursday's lecture is like one of my favorite ones to teach. And yeah, that's about music. There's a lot of really cool things related to that. And then yeah, that's the holiday. So next week, Zach, I'm going to start on Coulomb forces, then electric fields, Gauss's law, then we have an exam. And then the next week after that is electric potential, capacitors. And then the final week after that, or actually, sorry, there's another week. Current resistance, Ohm's law, circuits, Kirchhoff. And then finally, charging and discharging capacitors, and then how voltmeters and ammeters work. And then I do like a little review for like 2 days, and then we have a final. So yeah, we are almost a third of the way through the class already. Just crazy. It goes by so quick over the summer. To be fair, though, I've had teachers that simply give 100 for doing it so. For doing what so, sorry. Oh, for exams. Yeah. I mean, I'm very curious. So, I mean, there is a department guideline where they say they want the average GPA to be around, I think, a 3.1 for the class. They want the average to be that. And my in-person class that I teach, I'm pretty good at getting it to, like, you know, a 3.1. Online gets trickier to try to get the average to be that GPA. Last year, when I taught it online, AI wasn't, you know, as beast mode good. So students weren't able to like get 100 on stuff. And then it was pretty easy for me to tell if they were using AI. And I could also trick the AI with putting like funny things on my diagrams. But nowadays AI is so good that I don't think it's going to be possible for me to prevent everyone from getting an A, basically. I don't know how you prevent it without requiring some sort of like in-person, you can't use AI. I mean, the hope is that people still have some sort of integrity and they're going to want to learn things because they need to learn things. And if you just use AI to cheese your way through the whole class year, you're going to get screwed when you have to take the next class in person. But who's to say that someone wouldn't do it the right way? Like, they would try to do it themselves, and then at the very end, just be like, let me just make sure that it's all just correct. Saloni, what's up?
Oh, hi. I just wanted to talk about the kudu problem. I
Yes,
think I'm still
please.
facing it.
Yeah, which kudu
Actually,
problem you want to talk
I
about?
Okay, so I opted out of the Pro and One Access,
Good.
and then I emailed the Kudu support team if they could help me out with the subscription.
Yes.
They said they would, but my access is still there, but I haven't paid anything, so I don't know if that's creating problems.
Oh,
for
you're
me.
fine. Yeah, honestly, like, if they don't get back to you, you just get it for free, basically, at this point.
Yeah, and I think I'm not for the in-clicker questions. I've
Yes.
observed if I answer it after 7:30 p.m.
Yes.
it just marks it as completed, and it doesn't let me attempt it.
Interesting. So, wait, 7:30 what time? That's the question here. What time zone?
7:30 p.m. PST. No, it's
PST?
within the deadline. I think
Oh,
it's roughly. Yeah, because every time I've attempted the in-clicker questions around
Yeah.
the time of the lectures, it worked.
Okay.
But when I tried to do it later, it didn't work. It always marked it as completed.
How much later after the lecture? That's the question.
Within the deadline, within 12 hours.
Within,
Not.
yeah, it's
Um,
technically 11 and a half hours, I think, technically. Is
Oh yeah,
'cause-
within that for sure.
yeah, way within that, yeah. And it still shows it as being open, like it's not due yet.
Yeah, it still shows it as open. It just shows completed, and it shows me a 0.
Oh my god, dude, this whole fucking app, dude, is being so terrible. Yeah, okay, all right. So one sec. So here, for instance, well, let's see. Can you do it right now? Does it not let you for lecture 6 clicker?
Oh, lecture 6, I already did it because I was awake. But for lecture
'cause you're awake.
5,
Yeah.
yeah, 2, 4, and 5, because I was worried about my clicker. That's why I made sure I did it within the
Sure.
time limit
Yeah.
this time. But I don't know, for 2, 4, and 5, it just marked me as completed. It didn't even show that I missed it. It just showed completed and
Did
gave
it show
me
the
a
answers?
0. Yeah, it showed the answers, and it was
okay.
in-
So that means, let me think.
I don't know if it's because of my subscription. That's what I was
No, it shouldn't be because of your subscription. The subscription doesn't really matter, honestly. No. Especially if it's working while we have it open during lecture. It would be weird for it to not work after lecture, because what I do is I have the clicker questions close at midnight of the same day PST that they air. So they open at 12:30 p.m. and so they close at midnight, so that's 11 and a half hours later. So as long as you're within 11 and a half hours, it should allow you to still submit things.
I think I put a post about it on Campus Fire, and a lot
Alright,
of
let's
other
see.
people are facing it too.
Which one was it?
Lecture 2 and 4, yeah, the bottommost one.
Oh, these right here. Yes. Okay, yeah. So 2 and 4, I'm totally just going to give full credit for those, because that's within the first week, and there were a lot of things broken in the first week. There were things where you would click on a clicker question, and before you even hit submit, it would already mark it as correct or not. And I was like, okay. So don't worry. 2 and 4, I'm totally going to give full credit for. I thought by 5 they should be working. Right?
I'm not sure. I don't know if 6 had the same problem because I did it during the lecture.
Okay,
but
cool.
5, yeah. And the thing is, it just shows complete. I don't know if it shows
Yeah, so
incomplete if it
this will show oh, so interesting. Sorry, did it show complete on here, or did it show complete on one second. You know what I need to do? Let me pull up the student view for it. Let me pull the student view. Also the clicker questions allow you to put any answer in right now, because they'll still count. I got to get that fixed, or I just have to yell at them more to do it. I can't fix things, unfortunately. They have to fix things. I can fix your grades though, so don't worry. Anything due to errors and bugs is not going to be your fault for grades. Okay, so let's see. All right, so if I go into here, for instance, lecture 6, it'll still say live, because the clicker question is open, but I haven't answered it yet. Oh, actually, I did answer it. Never mind. Sorry, because I did this during class. Okay. And this one says it's okay. But also, where does it say 0 points? Is it up here? Is this, where does it say the 0 points thing? I'm curious.
I can open my Kudu again.
Yeah, can you just show me real quick? I'm just curious. Where it says 0.
Should I share my screen?
If you can, see if you can. I don't know if it's enabled on here. You can also like just take a screenshot and just you should be able to attach it somewhere. Where can I put where can I put screenshots in? One
Should I just
sec.
put it to Campus Wire?
Yeah. Just DM me on Campus Wire real quick, just so I can see it.
Okay.
Boom, 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 dum, dum. Let me see. I Spy discuss. What's up? What did you? Oh, did you submit your thing, I Spy? Let me see. Oh, you did. Oh, there is a lot of stuff. Okay, cool. And you sent yours. Let me go check. Let me check that real quick. Oh, where's my DMs? There we go. Clicker. Okay, cool. Let's go check it. Interesting. Okay, so it has a score there. I don't see a score on my side. The hell? What? Oh wait, no, never mind. No, never mind. I do see a score. I see a score here. It says 5 of 3.
Yeah.
Interesting. Oh, you know what's happening also? If people select, I get this. Okay, because this has been happening. You'll select any answer choice, and it'll say that one is wrong, but then it'll it'll say that one is right, but then because of that you can't change your answer, right? But then once the clicker question closes, if you had chosen the wrong one, even though it marked it right, it'll now mark it as wrong for the question after it closes. Okay, I think I understand more and more what's like bugging out here.
Oh, it didn't let me select anything.
Yeah,
Like, when
yeah. I understand it probably didn't let you select anything because, did it already have things selected?
Yeah, I already showed that the answers were marked and it was correct.
Interesting. It already showed that the answers were marked and it was correct, but it said 0 points for you, and so it didn't say anything like, here. Do you see on my screen here where it says like your answer, correct answer? You submitted your answer correct, right?
Initially, I think it was showing you submitted.
Interesting. Okay. Short answer is don't worry about this. You won't lose any points. You'll get full credit for things. I have a meeting with the devs like on a Zoom call on Thursday, and I'm gonna like really press for this thing to get fixed immediately because this is kind of an important thing that I would like to like count. But for now, as long as if it happens again, so for instance, if you're not, I agree with some time zones, it really doesn't make sense to wake up for lecture because it's super, super early. But if for another time you watch the lecture afterwards and then you go to try to submit it and it says they're already selected, can you put that on Campus Wire right away just so I can see the time and everything and like make sure it's not something wrong with the scheduling?
Okay, yeah, sure.
Cool. Okay. But otherwise, yeah, slowly. Don't worry about losing points on the clickers. You're not gonna lose any points. I'm just gonna get full credit for it. It's not your fault.
Okay, alright, thank you so much. Also about the discussion worksheet, am I supposed to talk to Gail about it?
Yes. Yeah, Gail is in charge of anything discussion worksheet. So if you missed something or you want to turn it in late, I'm letting Gail kind of like decide that, how much leeway. He should give leeway at least for like the first one, because people are still trying to figure things out. That was on Wednesday. And I think the next discussion section was Monday. So if you had to miss it for some reason, just email him and see what he wants to do about it. But I'm giving him
Okay,
kind
I
of
got-
the authority on that.
Yeah, I got confused because most of the platforms adapt to my time zone, but
Yeah,
Grade School doesn't. So then I got confused with the deadline.
that's okay. Yeah, explain that to him, and he should give some leniency on like the first couple ones, but it's really important to try to convert things to whatever your time zone is, so that because software is terrible sometimes, and it doesn't always work, but yeah.
Yeah, okay, alright. Thank you so much. Have a good evening.
All right, thank you. You too, Saloni. Enjoy. All right, let me see. Send them the doc in an email that will pull their IP, then DDoS them when they open it. Oh my God, stop. Femvox is right. But the next in-person class will probably get moved online as well, just like all the classes these days. Yeah, it is a worrying trend, but then I think education is just going to go really, really downhill. Just noticed, Dr. Gold, you have a similar voice to the kid from The Sixth Sense. Isn't that kid like 12 in that film? I know I have a high-pitched voice, but I don't think I have a 12-year-old voice. Okay. I mean, it already has gone downhill, but if everything goes fully online, it's really going to start going downhill.
Oh no.
It's going to go really, really downhill real quick. Okay. All right, yeah. We'll wait until if any of the other students come in, we'll do something. Otherwise, yeah, let's spin the wheel. Kashyyyk Techno, I might try these later, but I'm kind of tempted just to do. Let me do these first. I'll spin for these during the regular hour, but I don't want to get stuck on these and then like another physics student comes in and needs help. This I can help out real quick with. This is from, is this iSpy? Is this you, iSpy? Boom, 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 boom. Let me see the chat. Here. Can I not respond to chats? I thought I totally could. It's annoying. Okay, whatever. Okay, iSpy asked, if alpha is a root of the equation 4x squared minus 2x plus 3 is equal to 0, then the other root is, yes, slide and divide. Slide and divide. It's a fun one. Do I remember slide and divide, though? Okay. If alpha is a root, that means that x minus alpha is a factor, right? So, for instance, easy one, right? If we had x squared plus 5x plus 6 is equal to 0, right? We know that this factors into x plus 2, x plus 3, right? These are the factors, but the roots are -2 and -3, right? Because it's whatever causes this thing to be equal to 0. So, in general, a factor is x minus the root. Okay? So, if we have the equation 4x squared minus 2x plus 3 is equal to 0, okay? Then this is also equal to x minus alpha times the other root, which is x minus beta, right? Cool. Okay. So I think what we're going to do, in order to solve for this, I think I want to take this and I want to divide this, right? And see what I get left. Maybe it's something cool. And then we can solve for what beta is. I think. Yeah, because that should tell me what x minus beta is. Let's just see. I'm just curious, actually. So, let's move this over. Solve for the roots and pick. Yeah, that's another way to do it. That's probably the easier way to do it with the multiple choice. Let's see if we can do it this way. I want to see. Okay. So, if I do, was it polynomial long division? Actually, which way do I want to do it? We could do synthetic, or we could do. Let's do this way. X minus alpha, right? And then this is. You don't understand this problem at all? It is kind of interesting. Wait, don't you need a 4 on the right side so the coefficients match? No, I don't think so. Or, okay, wait, maybe actually, in order to get the 4 to match, one sec. Because, yeah, sometimes this is like 2x minus 3 or something. Uh-huh. Okay, you are right, actually. You are right. You're right. You're right, Jeff.
My name is Jeff.
Jeff. Yeah, okay, let's do that. Let's put a 4 in front. Totally correct. Okay. So let's divide it by 4 then, I guess, as well, right? Okay. I missed that sound alert. Yeah, okay. So what's that? That's x squared minus 1/2 x plus 3/4. Okay. And then we say, okay, how many times does x go into x squared? Well, that's going to be x times, right? So we multiply through, and we get x squared minus alpha x, right? Okay. Subtract this. This becomes 0. And then this is going to become alpha x, alpha minus 1/2 all times x, right? Yeah. Okay. Okay, then how many times does x go into alpha minus 1/2 x? I think you have to write 1 over alpha minus 1/2 here, right? Kind of goofy. Or no, sorry. You have to write alpha minus 1/2. That's what you have to do. Right? Because then this times this will get me my alpha minus 1/2 x that I need, right? From this to cancel. And then I'll have minus alpha times alpha minus 1/2. And then I'll pull down the 3/4. So then I'll get alpha times alpha minus 1/2 minus 3/4. Wait, no. Plus 3/4, right? Yeah. Okay. And then this is the remainder, but then it's remainder divided by that. What's up, I Spy? Why do you keep spamming the H's? Oh. Yeah. Okay. So then what you're left with is x plus alpha minus 1/2, and then plus alpha minus 1/2 plus 3/4 all over x minus alpha. And then this is all equal to x minus beta. Okay. We're trying to get beta by itself. And I hopefully want all the x's to go away, right? Is that gonna happen though? Okay. Well, this will go away at least, right? This will cancel with this.
Emotional, damn it!
This shit's whack as hell. Yeah, it's kind of fun though. Okay. I made it complicated. What's an easier way to do it then? Unless we just want to like literally just do the roots. I mean, we could do that. I wanted to see if this worked though. Is the way to do it to just like do the roots and then just see what the other one would have been? Like how one relates to the other? Because in 4 times 3 would be 12. And so we say what multiplies to 12 but adds up to -2. Now wait a minute, does anything actually do that? Yes. Wait. 1 and 12, 2 and 6, 3 and 4. Yeah, nothing actually comes out very nicely here, no, doesn't it? Oh, fuck. Do you have to do the quadratic equation? Femvox, what's the secret? This is not a regular ass question, by the way.
Oh no.
This is someone fucking trolling me. Being like, oh, it's just a quadratic thing. This is not just a quadratic thing. The product of the two roots. Sorry, my fucking throat. Yeah, there's a name for this. What's this rule called? It's Is it the rational roots theorem? Right, it's the roots of 4 divided by the roots of 3. Yeah, but then there's another thing about it's some rule about roots of a polynomial, of a quadratic, sorry. Okay. There's another name for this though. What is it? Lagrange. Yes, Vietas. Thank you. Yes. That's the one I was thinking of. Yeah. Yeah, the coefficient of the roots of a polynomial to the sum of the products of its roots. Yeah. It's the Sridharashiris method? I don't know who that is. Yeah, this is it, right? The roots R1 and R2 of the quadratic polynomial satisfy this. Yeah. I wanted to do it this way. I felt like this was kind of a cool way to do it. The issue is that you still have an X left, which, yeah, I don't know how I'd get rid of the X. I feel like we did this correctly, though. Right? 4x squared minus 2x plus 3 has to be 4 times x minus alpha times x minus beta, right? So we divided by 4, so that's 4, negative 1/2, 3/4. And then I just tried to put things into it. So alpha minus 1/2 x. So alpha minus 1/2, right? Yeah. Alpha minus 1/2 x. Cool, that cancels. Minus alpha minus 1/2. That alpha squared term in should have been a red flag, yeah, maybe. And then it's 3/4 plus alpha minus 1/2. And then that's all over x minus alpha. And that has to equal x minus beta. That's true. I want to know why I'm missing one more x, though. It's because of this little. It's because of this pain. This is a pain. Okay. This is another thing too, right? So alpha plus beta has to equal to negative b over a. So that has to equal to 1/2, right? And then alpha times beta has to be equal to 3/4. And then at this point, this is just easy, right? Because then you just say, oh, well, beta equals, yeah. No. So alpha equals 1 over beta times 3/4. But I want to keep things in terms of alpha, though, right? Wait. Oh, I think I can just solve for it and then just put it in terms of alpha. Right? Yeah, okay. So, what do we get? We get 1 over beta 3/4 plus beta is equal to 1/2. Oh, then this is another quadratic we're going to have to solve eventually. Oh, that is just literally the same thing, right? It's still pretty complicated. Yeah, we'll see. This is going to be the same thing, though. We're going to get the same equation. That's going to be, yeah, 4 beta squared minus 2 beta. Plus 3. I would think we can get it from just this, though, dude, right? I have 2 equations and 2 unknowns. Why can't I solve it? Is this JEE?
Oh no.
No, dude. I have a ban on JEE questions.
Dancer extraordinaire. Wow.
Because they're just frustrating. They don't really teach you anything. They just teach you to hate JEE questions. You have to know, like, some obscure method to solve them. Because I get 2 solutions for beta, and I get that. Because then beta is either one of the roots or it's the other root. Oh, man. Right? Yeah, okay. I have an idea here. Oh, that's cool, Atulio. You want to drop a link? Show us what you do. I fucking hate JE.
No.
It's not my demographic. Okay. You might not say it's advanced. I say it's advanced. And I have the PhD in physics, so. Okay. If I wanted to solve this, right, with just a quadratic equation, that would be 2 plus or minus square root of 4. See, wait a minute. Isn't this going to be like... Oh, man. Negative b plus or minus square root of b squared minus... Why are these imaginary then, though? The hell? 3 over 4 alpha is equal to 3 over 2 times 2 alpha is equal to 3 over 2, where the last result is due to alpha being a root of the given quadratic. I'm going to get imaginary roots, though, no? It's kind of whack. What's the discriminant? The discriminant's negative. Yeah. It's negative, though. You're going to get a negative discriminant. Yeah, there's no real roots. Okay, I guess we can just solve it complex ways, right? It's kind of a weird question. It's kind of like saying, which of these strange convoluted ways of writing the other root is not correct? Yeah, what's up, Yusuf? This is not grade 12, do not worry. Okay. So you get 2 plus or minus. And so are you just going to pick one of the roots? Negative 44 over 8. So I can pull a 2 out at least, right? So 2 plus or minus 2i. Square root of 44, right? Or square root of 11. All over 8. So that's going to be 1 plus I square root of 11 all over 4. Plus or minus, I guess. And so one of these roots is either alpha or beta, right? So these are the two roots. And you want to say how they relate to each other, I guess, right? Uh-huh. Alright, so let's just pick one of them. Let's just say, like, assume that beta is equal to 1 plus I squared root of 11 over 4. Yeah, exactly. No, I got you. And then alpha times beta equals 3/4. From Vietta's, yeah. So, alpha times 1 plus I squared root of 11 over 4 has to be equal to 3/4, right? Cancel the 4s. Alpha is equal to 3 over 1 plus I squared root of 11. Oh, no, sorry. We wanted beta in terms of the other one. Oh. Wait. What? This is such a mindfuck of a question. Yeah, wait a minute. Wait, can't I just say this? Can I just say alpha is equal to 3/4 1 over beta? Or that beta equals 3/4 1 over alpha? Oh, dude, I'm so dumb. Yeah, the answer is just D. Oh. Bro, we didn't have to do any of this shit. Bro, we didn't need to do... It's not D? Oh, wait. It has to be on the other side. Yeah. It has to be 3 over 4 alpha. Sorry, is what I meant to say. Wait a minute. How can any of these other ones work? Ugh, this question makes me hate math. It's C because that factor in the parentheses is a nasty way of writing 2 alpha. Interesting. Yes, I see that it's a troll. It was close. Okay. Wait. You're saying that 4 alpha squared plus 3? Oh, I see. Okay. Well, I think I see. I need this thing to be equal to 2, is what you're saying, right? Sorry, equal to 2 alpha. How can I prove that's equal to 2 alpha? Oh. Because that's just literally... Yeah. Because it's the root of the quadratic. Okay, I see. Because if I say 4 alpha squared minus 2 alpha plus 3 is equal to 0, that's the original thing. I see. Okay. So, this is true. And answer choice C is equal to 3 over 2 times 2 alpha, which is equal to 3 over 4 alpha. And there you go, you did it. Okay, great. Whatever. It's a really fucking dumb question, but... Yeah.
Well done.
Okay. Okay. I see it. I see it. I generally don't like questions. Dude, this is why, yeah, fuck JEE, dude. Like, what? That required you to, like, reverse engineer the answer choices to figure out what it was. And it was, like, hidden. That doesn't do anything to teach you about math. It just teaches you to hate, like, doing math. Yeah. I don't know. This is why I have strong disagreements with the whole, like, format of this exam. Like, I get it. It's clever that, but you had to go through the answer choices and be like, oh, well, this is technically the same way of writing that. So it's just dumb. It's dumb. It's dumb. It's dumb. It's dumb. It's dumb. Dumb. I've never been more frustrated at a math question. Okay. But okay. Cool question. It was cool. It was frustrating, but it was cool. There's at least some learning involved in struggling in how to solve it. We went through a lot of cool methods. So we went through trying to do polynomial long division. This method usually works for things. Yeah, it was a fucker of a question, dude. And then we went through Vieta's, in which I just tried to basically solve the quadratic. And then it turns out that, like, using Vieta's in combination with using what the actual quadratic was the way to solve it. Yes, I learned many interesting things. I did. But I think to anyone who's, like, trying to get into math, this would discourage them from it pretty quickly. But yeah, that one took 28 minutes for us to do. Okay. I'm done with my office hours, so let me go put this on regular Discord. Yeah, okay, cool. Oh, and I see you did the paper folding one, Fembox. That's cool. The rare F-bomb from Femvox. I agree, dude. I agree. Let it out, dude. I would let it out for that one, dude, for sure. The logical answer to it, anyone normal would say, is that it's the conjugate. The conjugate? What do you mean the conjugate? Sorry. Oh, that is just the 3/4 alpha?
The conjugate, when you pick the right every complex number like a plus bi, a plus bi's conjugate is a minus bi.
Oh, I see. Yeah, and I guess it was, right? Because we got this to be the roots, right? And so this is, yeah, a plus bi, so the other root is a minus bi. Cool. The paper folding one gave me an excuse to have some Desmos fun this morning. Yeah, what was it? This one? This was kind of a cool. Wow, you did what what's his face? Jeff would love you.
My name is Jeff.
Because you used a coordinate system. Jeff loves a coordinate system. Yeah, you did an equation of the folded line. Wow. Wow, that's cool. Every time I play around with Desmos, I come away enjoying it just a little bit more. Yeah, that's cool. And then here's the Desmos you had for it. Okay. Fold so the bottom corner lands here. Okay, wait. So. Oh, okay, I think I see what's happening. You're saying that, yeah, the bottom corner here would land up there. Which, right, yeah, if this was a square.
I threw that last question in the chat so that it would it, just like see where the source was from. Yeah, it was actually like pretty easy.
Okay.
We made it really common. You could just say that 4 alpha squared minus 2 alpha plus 3 equals 0. Plug that in, move the 2 alpha over to the other side, and then just solve.
And then just solve. Yeah. Where was it? It was on. Sorry. This one? Or no, this is a different one. Oh, this is the chain one. Yeah. And this is another geometry one. Okay, cool. Okay, cool. Let's see. I want to like do something that's like not just ridiculously like tricky, and then I'll spin wheels for other things. This looks also like a JEE question though.
I'm pretty sure we've done one just like this. Looks almost exactly like the Cayley's problem.
Yeah.
That we did.
Yeah, the chain that's falling,
The chain
but
falling.
it's a chain falling over the edge. This one's like a chain falling through a hole, and it pulls remaining links after it.
No, I think it's still the same because they
It's
say
the same one, yeah.
Without
Oh, because the other one assumed there was no friction either.
and-
Yeah, right.
Yeah, without friction or interference. So I guess the specifics of where it falls through doesn't really matter.
I think it was G over 3, right? Is that what it was?
Yeah, but also the whole like debate about it was that we had conservation of energy gives you, I think it was G over 3, and then the differential equation gives you, I think it was G over 2.
Right. Yeah, because the differential equation one like violates conservation of energy. I remember that. Yeah. You gave this one to me. I think we did this one together.
Yeah, it's the question like directly above the question that I posted today in the book.
It's a question directly above the question you posted today. Which one?
Yeah.
This one?
No, 242. No, that wasn't.
Oh.
I didn't feel like screenshotting.
What? God damn it!
It's like it guides you through the question.
Well, now I gotta go ask ChatGPT to OCR
I can
this.
just send you it. I have it open.
Okay, yeah. Can you just send it to me, please? Yeah, thank you.
Yeah. But it's one right above it. They literally it was conservation of energy is 1/2 G, and then the differential equation was 1/3 G.
Okay, once we can pull it up. Okay, what and this is page 242.
Yeah, but not on like the
Not on
it's
the actual
242
PDF.
on the PDF. No, it's 242 on the PDF. It's like 222 on the I think that's it.
Oh, wait 1 sec.
242.
There you go. Got it.
Yeah, it's that question right above. That's Cayley's problem.
Cayley's falling chain. Yeah, this was it.
Yeah, it's the same, basically the same problem.
Yeah. Yeah, and then we show that the chain falls with an acceleration of 1/3 G. But then we do it with conservation of energy. Right.
I think I want to say the answer was A for the velocity, the 2gx over 3, or root 2gx over 3.
Right. I can probably actually search for this one.
I think
good
so. And I
question.
think I have the solution to it in my OneNote somewhere.
Yeah, I know. Yeah, let me think. Breasticles. You've asked so many questions though, so I have to figure out which one it was. Oh, I found it. Posted 28 days ago. This is actually kind of cool. Look at this. There we go. This was the solution. Yeah, so we already did this. And we got that V was equal to the square root of 2/3 square root of 2/3 GX. Yeah. Okay, so we've done this question. So, one sec. Where was it? Okay. So, answer choice A was correct. Answer choice B was correct as well. Right? Yeah.
I think so. It's kind of a weird question to ask because, like, the whole, like, proposition about the
It's like it's a
question
paradox.
is, like,
It's
which
ambiguous.
yeah, it's like which one is correct? Is a given equation of motion correct, or is conservation of energy correct? And at least.
And then let's see, the amount of energy that they say that leaves, right, is it's 2/6 minus it's 2/6 minus 3/6, which is 1/6 mu L squared G, which I think is also the same thing we said here. One sec, where is it? I opened too many tabs. Yeah, 1/6 mu squared G, or mu. Let me get rid of all these. Okay, there we go. Yeah, mu GX squared, right, which was also this one. Yeah, mu GX squared. Okay. So I think A, B, and C are all correct. They said that that answer choice A is not correct. I don't know about the tension. I don't know where you would get that from. Okay. Well, here, I will reference that we did this one. I think I can link to posts. Yeah, copy the link. And who is this? Anurag. Yeah. I'll mark that as done. So there you go. Anurag, the link to us doing that one is right here. If you want to go through the derivation of how we do it. I just don't want to redo it again. I remember this one being a huge pain. Okay. Oh, and that's the one that you posted. Anyways, Breasticles. Got you. So that was question 4.
No, I didn't post that one. I posted the one below it.
Oh, okay. The brachistochrone?
Yeah. I think we had started on it at one point and then never finished it, but I don't remember entirely.
Okay. All right, let me see what I want to do. I don't want to do any of these questions, but I will do something because we are here. Or maybe Femvox I want to do. Maybe this one here. Let's do
got
geometry.
triangles, so it probably has a
This
line.
thing has for sure an auxiliary line in it. Yeah. Okay. We'll do this one, and then I will spin the wheel for like which question of doom I have to tackle next.
It's not that bad, and I already took the downfall of the fact that there's a typo in the question, And
Oh,
if
in the
don't
one you
realize that
submitted?
There's a yeah, he made a typo in it. If you don't realize that there's a typo, from experience, you'll spend about 3 or 4 days nonstop trying to figure out how to solve it, and you can't solve it because there's a typo.
Oh
So
no.
it just doesn't work.
Yeah, that doesn't sound like any fun.
No, not at all.
All right, let's see. In triangle ABC, point D divides AC such that AD to DC is 1 to 2. Okay. I'm going to draw some things. So I'm going to say if this is X, then this is 2X. Let E be the midpoint of BD. Okay. So I'm going to say this is equal to Y. And this is also equal to Y. And let F be a point of intersection on the line BC and AE. Given that the area of ABC is 360, okay, so they give us the area of this whole thing. Or whatever, something like this. $360. What is the area of EBF? Okay. So they want the area of this. Either learning or satisfaction. Yeah. I agree with that. There's that Nelson Mandela question, right? I don't fail. I either win or I learn. I agree. But at some points, like, I just don't want to learn anymore. I've done enough learning. I'd rather help other people learn than myself learn. Okay. EBF. All right. This is an inscribed triangle, right? Of, let's see. Technically that triangle as well, but it's not a 90. You need right angles for that to work. Yeah, the question is where is that auxiliary line they're going to ask me for? Yeah, I need some 90s. Coordinates? Jeff, no. Let's not do the coordinates already. Cough ordinates. Dun, 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 dun. I don't have any parallel lines. If I wanted the area of EBF, it's always useful to somehow get an altitude, right? Like if I could get this, or I could get this, and then this as well, then I could find the area of this. The 1-to-2 ratio intrigues me. So I wonder if I'm supposed to do something like with this triangle and like this triangle. Because then I know this length is 2y. This is 2x. Drop in altitude from B to AC. Ah, yeah, good point. Yeah, makes a valid point there. Oop, nope. So Jeff is right. If we know that the area of that is 360, then doing this at least tells me that base 1/2 times this has to equal 360. But then I don't know how that. Oh, wait a minute. But then this is a right triangle, and then this is also a right triangle. And they're both technically... Yeah, exactly. Yeah, whatever that... Yeah, 2 of those sides. Yeah, exactly. Okay. I'm just trying to see long-term how that's going to help me figure out EBF. Okay, let's see. So from triangle ABC, we know that 1/2 times 3x times, let's call that altitude something else. Let's call that altitude Z. Changing geometry bad to algebra good. Yeah, okay.
You could relate both triangles by trig.
Like sine and cosine stuff?
Yeah, because you could say like the sine of let's see. Yeah, let's call it like theta or whatever. Pick the sine, solve for your altitude, and then once you solve for the altitude, you can set them equal to each other. And that'll at least relate X and Y in some sense.
Okay. So I think... So which thing are you calling?
Altitude and Y.
You're calling Z and Y? And you're going to call this like some angle?
Yeah.
Yeah. Because... Let me think. Don't call that Z. You can compute it based on the area. Yeah, but I want to assign a variable to it. I mean, we got it from here, right? I guess, yeah, okay, fine. If you want to do this, it's equal to 720 over 3x, right? So what's that? 240 over x? Yeah. Yeah, and if I know the length of that... I can compute, yeah, this and this. Correct. Using y. But then this is also going to be unknown. Like, what is AB, right? Yeah. I think also angle wise, you know this is equal to this, right? It's just a damn shame none of these are 90s. It would help me out so much. And ABE. Cool, fam. I wanted to maybe draw an altitude here. And then I would have this right triangle and this right triangle, right? I don't know what that helps me out with here, though. I have a bunch of these. How do those help me out? Yeah, I don't see it. I don't see it. I don't see it. Let's see if chat can do it. Come here, ChatGPT. Time for you to eat some water bottles of water and make me feel less stupid. It happens. Some days we just get tons of difficult questions and I feel defeated, but it's fine. 1/12. Okay. ChatGPT says the answer is also 30. A clean way is to use coordinates. Look at this, Jeff.
My name is Jeff. My name is Jeff.
Jeff, dude, it loves the coordinates, bro. It loves the coordinates. Jeff's like, I fucking knew it, dude. Now D divides AC. So D is 1/3 of the way from A to C. Wow. And then we're gonna do the midpoint. I didn't even think about coordinates. This is Jeff's way to do it all the time, dude. It still looks like kind of a mess, though, man. Crazy that chat gets this. I'm guessing the solution is posted, though, if it's a American whatever math challenge question from 2019. Okay, cool. I'll share this, the coordinate solution for it. Yeah, that's cool. I was kind of hoping there'd be something pretty, but there it is. If you want the link for it. Kind of brutish. All right, I have 26 minutes left to get humbled by more things. Yeah, I wanted a geometric solution for it for sure. I think maybe there was only a coordinate way to do it. That's really annoying though. Okay, here, I'm gonna spin the wheel. Fate will decide.
Let's go gambling!
Without pen and paper, part 9, difficulty 9 out of 10. Gladiator, what's up, dude? Gladiator, do you need help with like one of your actual classes? I will throw away all these questions I'm working on and help you. I don't really want to do this. I really don't want to do it.
Obviously, don't go and do that. Please.
It's actually, if you just avoid any mathematical rigor, it's really easy.
Yeah. You're just pre-learning for first year? Nice, dude. Well, if you want to pre-learn anything, submit a screenshot of something you want to pre-learn. Give us something solvable. We haven't had a single thing solvable this whole stream yet. Breasticles is probably solvable. Yours is probably solvable.
It is.
Okay.
Mine is not too bad.
Okay.
And I have a written solution of it already.
Good. Okay, so we'll probably do yours next. We'll do yours next. I'll take like 5 minutes on this, and then I'm probably just gonna do yours. Okay. Let arctan be between negative pi over 2 and pi over 2. Standard definition for arctan. Then the minimum value defined by the function, minimum value of the function of this is. So I agree. Who said the minimum happens when the derivative is equal to 0?
That's overcomplicating it more than it needs to, but
yeah.
I think that was Jeff.
Can this value be negative though? That's the issue though, right?
I think you're overcomplicating it.
Okay.
What happens if we plug in 0 or x?
Right, I get 0 to 0, which is just 0. Right?
Exactly.
Cool.
Yeah.
But the question is, could I have gotten a negative area from this? And I guess maybe not, right? Yeah.
No, I don't, because it's going to be a exponential.
You're right. And this is always always positive.
Yeah, so the only time it would.
And then, but this could be negative though, right? But t is going to go from 0, right? So that would still be positive. Oh, is x arctan of x always positive? Yes, right?
No, but it's
not.
it's not. But since you're multiplying by x, it's gonna be positive. Because if you were to plug in a negative value,
Right.
like even if you plugged in negative pi over 2, which is
You
when
would
it
end up having x.
diverges
You'd have this for
to
pi over 2. Okay. Okay, I see.
yeah, and then the negatives would cancel.
Okay, so this is also always positive. So, then yes. Without loss of generality, we'll just say that the integral from 0 to 0 is equal to 0. So, is the minimum equal to 0? Are we allowed to say that? Jeff says, wait.
My name is Jeff.
That's what I got. That's what Cat got. Because even if you actually plugged it in to the derivative, and then
And yes, Jeff, I am saying
You
x
plugged it
arctan of x is always positive. Right? Thank you, Sam. How about Germany losing to Paraguay, dude? What? Oh no. Oh no, the World Cup. Yeah, I believe it is. And here, we can use Desmos if we want, right? Let's use Desmos. I'm gonna say x arctan of x. It's always positive. Right? Look,
Yeah.
that bitch is always positive.
because whenever it goes down to the negative values for arctan, the x is also going to be negative.
Yeah. Yeah. X arc
Technically,
technically what? Sorry.
I was going to say technically we could also make the argument, right, that we know it's going to be negative. That's x times the arctangent of x is a even function.
Yes.
Right, because we're multiplying two odd functions. So
Yeah, this is odd.
resultant is going to be an even function.
I like that. That's an even better argument. Right, this is equal to an even. Yes. And so, yeah, the minimum you can get on a value is when you take the integral from the start to the finish as being the same bounds. Okay, cool. That one wasn't so bad. Wow, we have a win today. Can we follow it up with a second win?
I think we can.
All right, let's do it.
Well done.
Kaushik. I can't believe the triangle one was coordinates. The one time Jeff is right.
My name is Jeff.
Not the one time you're right, Jeff. Sorry. The one time your suggestion of coordinates is correct. You're right a lot of times, but your coordinate suggestion is usually a rabbit hole. Like, I just don't want to go down.
In a way, though, technically it's not, because it's still solvable. It just may be, like
It's just a bitch.
exponentially harder with,
Yeah.
coordinates, but you could.
Femvox says there was a nice way using areas. Sorry. Okay. All right. Let's look at the brachistochrone. This is like when they have wire hanging from two beams, right? You have this. And then there's like a wire hanging from it. The wire will try to minimize potential energy, and it does so with an arctangent, I think, right?
I think that's a different question. And it would
It's a
be
different type of thing.
It's just it's a Koch curve, but it's still calculus of variations.
It's a catenary, that's what it is.
My name is Jeff.
Yeah. Jeff's right. It's a catenary, not a brachistochrone. Sorry. Imagine a tiny bead.
Brachistochrome is the fast. The videos when they're like, here's a straight ramp and then this super curved ramp and then the curved ramp falls way faster. It's that.
Okay, the wire entirely with one end. Wait, what are they saying? Due to a mass located at the origin, that is, the bead slides on the wire because it experiences an attractive radial force. Oh, we have done this one before. Yeah, I do remember this now.
Yeah, I think we started it, but I don't think we ever finished it.
Yeah, okay. We had like, yeah, okay, I remember. With one end at r comma 0, yeah. So one end is here. And the other one's at r pi over 3. Right here. And then there's a gravitational field that's pulling it in, right? Towards the center, I think, right?
Yeah. Like
and I want to know
like a point mass.
what I want to know, like how curved this thing should be. Okay. To minimize the travel time. Okay. Show that the initial potential energy of the bead is that, and that the initial kinetic energy of that is that. Well, I mean, that's not too bad, right? So, can I use physics for this?
Yeah. I don't see why not.
Kinetic energy is 1/2 mv squared. So that's gonna be 1/2 m. They said it has an initial velocity. Okay. Let me see what Fenvox says. Basically, is follow the length of the triangle A and draw 2 line segments to it from the opposite vertex that cut off the subinterval of length B. Then those line segments will cut an area of the triangle in the same proportion with the side length, namely B array of the whole triangle. Okay, I'd have to see that. It's hard for me, like, do that in my head. All right. Yeah. So V naught is equal to square root of 2 big GM over big R. So if we square that, so KE naught, that's just going to be 1/2 times 2 big G big M over R. And that's just going to be G big M little m over R. Cool. Win. I like that. And then the potential energy is negative GMM over R. Okay, so for potential, you have to define potential being 0 somewhere, right? So they said, yeah, an attractive radial force. So, okay, so F is equal to negative, or I would say G big M little m over R squared. And that's in like the negative R hat direction, right? Like it points inwards towards R hat. So in order to define potential, we say that like negative grad U is equal to F. So U is equal to the negative integral, or like du, sorry. Du is equal to the negative integral of f dx. Oh, this is the one time, right? So this is negative du df. Negative du dx is equal to f, and I'm gonna split it.
By mathematical authority, this is bequeathed upon you that you may break up the dr dt.
I did it, Zach. I was allowed to do it. Oh, shut him out. Okay, but then I have to define like some potential. So I'm gonna say U0 to wherever like U as a function of R is, and we're gonna say that U0 occurs at R is equal to infinity. And then UR is going to happen at R. Thank you, Jeff.
My name is Jeff.
Appreciate you, dude. Okay. Yeah, what is this even asking? This is kind of like a physics question here, Gladiator. And then yeah, we're gonna take this to R, I guess. Yeah, okay, cool. So then UR minus U0, which is 0, is equal to negative negatives are gonna cancel. And so I have the integral from infinity to R of G big M little m over R squared dr. So that's going to get me negative big G big M little m over R from infinity to big R. And so, yeah, potential at R is going to be equal to, or I guess big R in this case is what I said, is negative G M little m over big R. Which, great. Yes, those do cancel. Yeah, so UE plus KE is equal to 0. Nice. Okay, cool. Hint, the potential energy. Yes. Okay, cool. This energy is negative because gravity is attractive. Cool. Nice. Okay, we did part A. I think that's cool. Let's go find part B, maybe. And then Gladiator, the last 5 minutes, I'll save to do your question because we can do your little integral to evaluate for sure. Wait, what? Did I have it open somewhere? Oh, here it is. Okay, here we go. Yeah, night, Jeff.
My name is Jeff.
Okay, part B. If t is the total time for the bee to travel, okay, then t is the integral of dt, where ds over v, where v is the instantaneous v to the speed, and ds is differential path length. In polar coordinates, ds is dr squared plus r d theta squared, and thus ds is equal to d theta squared of dr d theta squared plus r squared. Cool, so this is like arc length, basically. Invoking conservation of energy, show that t is equal to that. Fascinating. Okay. So t is equal to the integral of ds over v? I guess, are we going to write... Alright, so ds I think we're going to write in terms of this. And then I think we have to write v probably in terms of... I don't know. Oh, in terms of the sum of kinetic and potential energy has to be equal to 0, right?
And then I want to say it should be on the interval 0 to pi over 3.
Is that the... Oh.
Yeah.
Okay. I see, because, yeah, you have to go from the angle 0 to pi over 3, right? Yeah. We're going from r comma 0 to r comma pi over 3. I agree with that. That's cool. Okay, but then this was all over v. But then by conservation of energy, 1 half mv squared. So 1/2 mv squared plus potential energy, which is minus gmm over r. So minus g big M little m over r. That has to be equal to 0. Okay. So that means we can cancel out the little m. So v squared is equal to 2 big G big M over r. And then I'm going to square root that, I guess. Okay.
Yeah,
and then I'm gonna.
That's correct.
And then we'll plug this into here. What's that gonna do for us? Okay. I see. So, but square root of 2gm is a constant. Okay, very cool. So it's 1 over square root of 2gm. Integral from 0 to pi over 3. And then this is d theta. And then this is going to be square root of dr squared d theta, or dr d theta squared. And then we're dividing this by r. Plus r cubed d theta all over r. And so, ooh, wait a minute.
It should be multiplying by an
You're right.
r.
Sorry.
And
Sorry.
it
If I'm
should be,
dividing,
r
divide by a
r
fraction.
squared instead of r cubed.
Yeah. Yes. Wait 1 sec. Yes. Totally correct. I fucked up a lot of things here. Sorry. This is r squared. I'm dividing by a fraction, so r goes on the top. Yeah. Okay. Got you. Okay, cool. So then, yeah. I agree with that. This is cool how it incorporates a lot of physics. Okay. Let me see how much of part C I can get. And then, what did you submit to me, Gladiator? Integral of arc sine squared? I don't know if that's an easy one. I think this one actually kind of sucks. No? Yeah.
It'd be like a really ugly part.
Yeah, it's a really ugly integral. Okay. Okay. To minimize t is a problem beyond ordinary freshman differential calculus.
Oh,
Okay.
also this is where the typo comes in.
Ooh, where's the typo?
It should be in the equations down at the bottom they give. It's the r prime on the 2. That should just be an r. It should
Okay,
be
gotcha.
5r prime plus 3r squared equals 2r r double prime,
Gotcha.
and 3r prime squared plus 3r squared equals 2r r double prime minus 2r prime squared.
Well, there's only one equation down here, right?
Oh yeah, that they read it in D as well. They read a rearranged form of it.
Oh, okay.
Oh,
gotcha.
it's not the square on the 5r prime. It's prime on the 2r prime r double prime.
This one should go away?
Yeah, that should just be an r.
Okay.
Yeah, that typo cost me 3 days of my life.
That would suck. Okay, if we write the integrand of the t integral as k is equal to r prime squared plus r cubed, where r prime is dr d theta, then dk minus dd theta of dk dr prime is equal to 0. Interesting. Oh, I see. We're trying to minimize t. And a fundamental result from the subject is Euler-Lagrange. Oh, okay. I think I'm starting to see it. It's weird because we have... Right, okay, sorry, there's no d theta here anymore. This one's gone. I don't know why I wrote another d theta. I see. The d theta is outside of the square root. That's also kind of like not very well written. I guess, yeah, they should have done this. Okay. Okay. I'd have to remember how calculus of variations works. But I guess they're calling this like K. I guess that makes sense. Okay. This result is derived in any book on calculus of variations. When Lisa's best. I give it without loss. What does WLIB stand for? Oh, no, that's his book. Sorry. Okay. In a letter to the then teenage, Lagrange wrote to Euler, use the Euler-Lagrange equation to show that the required R theta satisfies this differential equation. Okay. Okay. So, partial K, partial R is what I need to figure out, right?
Indeed it is.
How does that work when I have R primes? Are those two different variables? When I do
No.
partials?
No, because it's still in terms of R.
Yeah, you're right. Okay. Okay, so that's going to be
R
1/2 R prime plus R to the third to the negative 1/2. And then we have to do chain rule and product rule. So then this is going to be R prime to the third, right? Plus 2R double prime plus 3
it also
R squared.
it might help if you factor out an R from the square root,
Yeah.
because then it's less product rules and chain rules and.
You mean just pull out a square root of R basically, right?
Oh yeah, sorry, it's square root of R, not an R.
But then I still got to do a product rule between that and the other thing. No?
Yeah, true.
Yeah, I think I'm fucked either
I
way.
guess either way, it's.
Yeah, you just get wrecked.
Oh shit, not good.
Okay. Yeah, wait. Man, my brain is done at this point. Okay. If I need to do DDR of R prime, right? This just becomes R prime plus R double prime. Is that correct?
I want to say it should be R prime squared.
Okay. No. Well, wait. Let's remember what R prime means. R prime is dr d theta.
Oh yeah, it is.
So DDR doesn't actually care about that, right?
Mm-hmm.
Yeah, it's if we do dd theta. Oh, so wait, this is just equal to R prime. No?
I don't think so, because I got it's equal to 3R squared plus R prime squared over 2 square root of R square root of R prime squared plus R squared.
What do you think? Ugh. Because this is what it actually is, right? So if I'm just doing the first, I'm not saying the whole thing is that. I'm saying if I just do this first part of taking the partial of this. Oh wait, I also I fucked up a squared here. That's why. Wait 1 sec. Okay, 1 sec. This is R prime squared plus R cubed. Cool. Chain rule. Now I need the derivative of what's inside. I need the derivative of this, basically, with respect to R for the first part. That's going to be dr times dr d theta squared plus d squared r dr d theta, right? Times r. Or actually, no. Sorry. It's even weirder, actually. Sorry. It's dr times that plus not doing the derivative of this, and now this is 2 dr d theta.
I think we might need
And then this
chain
is
rule in this
Then this
case.
is d squared r dr d theta, right? No?
Yeah, but we r is a function of theta.
Yeah. But I'm doing DDR, right? Partial r. Ugh.
Yeah, but because of the chain rule, it
Right.
would, if r is a function of theta and we take a derivative with respect to r, then these are the times when I really wish I wrote in intermediate steps.
Yeah, no, because it's partial r. One sec. Let's ask chat. See what chat says. Is it the Paul Nolan textbook? I don't think so.
No, it is.
Oh, it is it?
The Paul Nahim, yeah.
Let's just see. I'm having to remember how like basic like partial derivatives work. Yeah, okay, for partial derivatives with respect to r, you treat r prime as a constant. So yeah, it is what I thought it was. So then it's just r prime squared. And then this is 3r squared. Yeah. Yeah. Okay. Do you see that, Brescals? Like, yeah, r prime is...
yeah, I do.
R prime is a constant.
That's the same result I got too.
Yeah. Okay. So that's this, and then it's times the derivative of what's inside. That's just going to be r prime squared plus 3r squared. And then this is... Yeah, just how it is. Okay. That's dkdr. dkdr prime. Same thing for the first part. But now I treat r as a constant. And so this is going to be 2r r prime plus 0. Okay. Okay. But then I want dd theta of this. Okay, so this is where r's are going to turn into r primes, and r primes are going to turn into r double primes, right? This is kind of a mess, though. Yeah, this sucks. And then what are we going to want to show? We want to show that that satisfies this differential equation.
Yeah, and you can save yourself a bit of effort in the writing if you recognize that the partial k by partial r prime is technically 2r r prime divided by k. So when we take the derivative, we can just call it k and k prime and do a quotient rule.
Oh, okay. I see. Yeah, this is the same. Okay, so this is the same thing as r prime over k, is what you're saying?
Yeah.
Oh, okay. So then dd theta is derivative of the top, which is a product rule still, right? So this is going to be r prime squared minus r double prime, right? No, wait, sorry. Oh man. But this is still a product rule, though.
Yeah, so that becomes if we do the quotient rule first,
Yeah.
right? Because k is a function of r and r prime, we would get k times r prime squared plus r double prime minus r prime k prime.
Yeah, okay. So you're going to say r prime times k minus r prime k prime all over k squared,
all
right?
divided by k squared.
Okay. But then this is a product rule. This is r prime squared plus r double prime times k minus r prime k prime all over k squared, which k squared is r prime squared plus r cubed. Then what do we say? It was this minus all that was equal to 0. So I'm just going to say they're equal to each other. Move that to the right. And then this was 1/2 r prime. Oh, maybe I wanted to leave this as k squared for a second.
Yeah, I would just leave it as k squared.
I think so too. Because then this is going to be 1/2 k, or 1/2 1 over k, right? So 1 over 2k for this part. And then that's going to be r prime squared plus 3r squared. So now k's will cancel here, right? And I get r prime squared plus 3r squared is equal to 2 times all of this garbage. And then this is all still over k, right? So one of these will cancel, right? And now this is just over k. Okay.
Yeah, and then I'll give you the time of substituting it.
Dude, what the shit? Dude, no, bro. Excuse me. Excuse me.
Oh, no.
Okay. All right, we're just gonna leave it at that. Okay, cool. Yay, we did it! Jesus, dude, all that algebra at the end, man. I appreciate the mercy killing, though. Yeah.
Yeah, though that's just like
it's a heater,
ungodly
dude.
amount of like, make sure you get your primes right.
Yeah.
Squared right.
I was looking at this, I was like, oh no,
right, and
this is about to get really bad. Bless you for. We worked on that for 31 minutes. Wow. The first parts were cool. I really appreciated the first couple parts for doing like the physics, but then yeah, this was just This is one of the hardest nights of problems I've seen on Actual Education. Yeah. It's okay. It has been pretty difficult. I will say, like, I understood this. I understood this. I understood part of this. And then this just becomes a nightmare. Just becomes, difficult. We could say, however, I mean, this question was pretty easy once we kind of analyzed the integral. This one wasn't too bad. This one, I had like no clue. This one shouldn't have been hard, but was just general JEE fuckery. And yeah. And then I taught physics. Okay, cool. All right, well, I appreciate, as always, like, I appreciate the workout. It's fun. Even if, I know sometimes it looks like I'm not having fun. At the end, I still appreciate having done it. But yeah, our next stream will be tomorrow, an hour earlier. We'll see if the UCLA physics students have some physics questions for us for the beginning office hours. If not, can always help out more things. And I'll make some announcements in the Discord. We'll do some fun stuff on Friday. So, cool. Let's see. Let's go raid someone. Let's go say hi to someone. Who are we gonna go say hi to? Top shelf stuff. Thanks, Feb. So who's doing some math? Actually, let's say hi to Mr. Aegis. I like Mr. Aegis. Mr. Aegis is cool. Mr. Aegis is playing a game. They did an interview for me for the Knowledge Fellowship once. They're pretty cool. And I like them. They're pretty active in my Discord. His books are peak. Yes, I hope you will try part 7 in the next stream positively. I appreciate your hard work. Thank you.
Good job.
Fem, you could do it much better than me. But yes, I inspire you all. Okay. Enjoy the rest of your Tuesday. We'll see you on Wednesday. Peace.